Okay, we're good. All right. Hello, everyone. Welcome to Concordia University's Force Space, and thank you so much for joining us for today's event, From Extreme Weather Attribution to Climate Litigation. It's a conversation with Dr. Friederike Otto. To help situate you, we are streaming to YouTube, and we are live from Force Space. And we are located here on unceded Indigenous lands in Tiohtià:ke, Montreal. And here at Fourth Space, we work with our university community to help mobilize knowledge by co-creating daily activities that examine research questions, projects, things in development across the university. We are running today's event as a live-streamed Zoom meeting also, so we welcome any comments or questions there via the chat. Those of you in the space during the Q&A, if you'd like to participate, and we want you to, please let us know. Just raise your hand, we'll get a microphone over to you. And with that, and to help introduce things, it's my pleasure to pass the microphone over to Professor of the Department of Geography, Planning and Environment, but also Concordia Research Chair in Climate Science, Sustainability, Dr. Damon Matthews. Damon, over to you.
All right, good afternoon, everyone, and thank you for showing up at last minute notice to this, what I hope will be a very interesting talk and conversation with Dr. Otto. So I don't think we've ever met in person, but I've been aware of Friederike Otto's work for more than a decade, I'd say, possibly dating back to your postdoc with Miles Allen when she joined the climateprediction.net project, which at the time was a revolutionary strategy to use idle computing time to generate thousands and thousands of climate simulations. And at the time was a very interesting and cutting-edge project led in Oxford. And so Dr. Otto joined this group and started off by publishing in Extreme Weather Attribution Science. Spent the better part of 10 years in Oxford as a leader of the Environmental Change Institute. Published a book around that time also, in 2020. Called Angry Weather, which I know many of you have at least heard of, if not read. And also in 2021 was named to Time Magazine's list of the world's 100 most influential people. So a quite stunning and humbling trajectory, and I'm very happy to finally meet you and have you join us today to share some of your knowledge and expertise. I think that's all I'll say. I imagine you will talk about the World Weather Attribution Project, which is one of your hallmark achievements in the last 10 years. And so I think I'll just pass it over to you and follow up with questions afterwards.
Yeah, thank you very much for inviting me here. It's been a long time since I've been in this part of the world, so it's nice to be here. I'll give a sort of 20-30 minute intro to tell you a bit of what I'm doing and why, but then hopefully there'll be questions and there will be more like a conversation. So as Damon just said, so the main sort of the reason why I ended up in the Time magazine and the main part of my work that you hear about is on this project that's called World Weather Attribution. And in that project, we attribute extreme weather events to climate change. So what does that mean? So I think, first of all, every time now an extreme weather event happens, people ask the question, is this climate change? And of course, that's not something new. That's something that has happened for, I would say, at least the last 20 years. And for a long time, lots of people would give answers to that, but not actually the scientific community. They would say, yeah, maybe it's the kind of thing we would expect, but the scientific community was really quiet on that. And so what we, with my team at the time, which is almost 10 years ago now, thought this is really not good, because we can give these answers, but of course when you do science, it usually takes a long time. So you take 6 months or a year to do the research, to write up the paper, and then it takes another year to get the paper through peer review. So when you have an answer that is based on scientific evidence, the the event has long passed and people have forgotten what it actually was about. So, but of course, we are living in the era of loss and damage, and the events that are happening today are to a large degree influenced by human-induced climate change. And often, and this is why I've got my friend Adam here on the slide, who was a PhD student at the time when I was in Oxford, but is now a journalist. And when we talk about climate change in public, it's often just about the future. It's about 1.5 degrees. It's about climate policy, but it's not about linking what we see happening today with climate change. And of course, and often also the way we talk about climate change in the future is as if when we hit 1.5 degree, something will happen, an asteroid will fall on our head, and we finally will all wake up and realize, okay, this is happening now. But of course, this is not how climate change works. And this is the basis of sort of the central idea behind the work, is to show us as scientists, because also we don't really know what is climate change here and now, which event is climate change and how much, but mainly also the public and everyone who's asking the question, what's the role of climate change, and well, even more so those who don't ask the question yet, but maybe should ask the question. So that's the idea, and I've always used this picture, but I realized that this is actually a really stupid picture to use, because we don't care about climate change because of the physical things, because of the record temperatures that we reach, even though that is usually what gets our attention. But we care about climate change because it affects people, and it affects the most vulnerable the most. And our continued burning of fossil fuels dramatically violates the human rights of a vast majority of the people on this planet. And this is why this matters so much, and why we need to talk about. Okay, so that's a preamble. That's why we're doing it. So what we're doing is we answer the question whether and to what extent human-induced climate change altered the likelihood and intensity of an extreme weather event. And this is just, so last year, in the last 12 months, we had 76 triggers about extreme heat waves. And so we worked in our team. Part of our team is based at the Red Cross Climate Center, and with that team, we have developed a trigger system that alerts us to weather events that affect a lot of people. So for example, for floods, we have if more than 1 million people are affected, or if more than 100 people have lost their lives, or if more than 50% of the population is affected, or if there is a national state of emergency declared, then we will consider doing a study. For heat waves, the criteria have to be slightly different, and we can talk about that later if you're interested, because humanitarian impacts of heat waves are not monitored globally, so we have to find our own way to identify that. But heat waves are, and that's why I want to start with that, the types of events where climate change is an absolute game changer, and they are the deadliest extreme events that we know, killing. I don't have numbers for Canada, but in Germany in 2020, more than 8,000 people died in a heat wave, and that's a not very hot country and a country with relatively little vulnerability. And the heat waves we looked at 7 out of the 76 that we could have looked at, depending on our criteria. We found in all of them that climate change played a huge role. That's not surprising, we wouldn't have to do a study for that. But actually in 6 out of these 7 extreme heat waves, we found that the temperatures were so high that they would have been impossible to occur without human-induced climate change. And only in 1 of them, that was actually an event that would have been possible still. So how do we know this? The idea behind event attribution is really straightforward. So when we, and this is an example for 2 heat waves that we looked at most recently, one in sort of West Asia, Palestine, Israel, Syria, Lebanon, and Jordan, and the other one over the Philippines, just to give you 2 examples of events that really had huge impacts just now. what we need to know is, first of all, what is this kind of event that we're dealing with? With heat wave, that is not so difficult because, okay, it's usually temperatures or temperatures combined with humidity. And then we have to figure out, is it over a whole month that the impacts were really severe, or is it just 3 days or 15 days? And in these two cases, we found that over the West Asia region, it was really that's over a period of 3 days. It was extremely hot and lots of fatalities occurred. So we used that as the definition. And then and for the Philippines, it was a slightly longer period. It was about 2 weeks. So we used that as the definition to characterize the heat wave. And then what we have to do is to find out, okay, in the world we live in today, what kind of event is this heat wave that we're interested in that we've just characterized? Is it a 1 in 10 year event? Is it a 1 in 5 year event? Is it a 1 in 100 year event? A 1 in 1,000 year event? And we can do that using observations and statistical models, and also climate and weather models. And we get something, and you can see this here as the red curve. We then get a distribution of possible heat in that part of the world at this part of the year. And we found that, okay, the heat wave that has just been observed, so in the case of the Philippines, in today's climate, it's about a 1 in 10 year event. So it's not hugely rare, actually, in today's climate. But then, of course, we haven't done the attribution bit, so we haven't found out what the role of climate change is. And to do that, because we know very well how many greenhouse gases have been put into the atmosphere since the beginning of the Industrial Revolution, we can take these out of climate models and simulate possible weather in the world that might have been without climate change. And in this case of the Philippine heat wave, you get a curve that looks like the blue one, where you also have a probability distribution, but you actually never, so you can see that this blue curve never reaches the temperatures that have been observed in the Philippines this year in April over this 15-day period. And so this is why you also, and this is just a different way of showing it when you look at this, this graphic here. So in a world without climate change, this event is statistically impossible, basically, to occur. But in the world we live in today, which is about 1.2 degrees hotter than it used to be, we have a 1 in 10 year chance of this event to occur. And of course, we can't just look at the likelihood of the event occurring, which is what I've just explained, but we could also say, okay, the same heat wave, so a 1 in 10 year heat wave, how different would a 1 in 10 year heat wave look like in a world without climate change? And this is what you see with these bars here, that this is where we are today. So the 1 in 10 year heat wave is a bit about 32 degrees. But the same heat wave, the 1 in 10 year event, would only be a bit over 31 degrees in a world without climate change. So there would have been a heat wave, but it would be cooler. And it might sound like, oh, 1 degree hotter or cooler, it doesn't sound very much, but it makes a huge difference for mortality and morbidity and other impacts of extreme heat. So that's what we do. Doing it, so the idea behind that is very straightforward. Doing it is often not so straightforward, but the principle is actually not that complicated. And so you've just seen some typical results for heat waves, where we always find a massive role of climate change. That's not the case necessarily for extreme rainfall events. So there, in most cases, we do find a role of climate change, but it's usually smaller. But of course, that doesn't mean that it doesn't matter. And yeah, these are just some examples. And again, the most difficult thing about, or the most intellectually complicated thing about these events, sorry, I thought by clicking in the right direction, is really how do we characterize these events. So all these results that you see here are for a very specific characterization of the extreme event. Okay, okay, here we go. And this is, no, that was too far. Let's back again. And because this is so essential, I just spend a few minutes on this, because this is for the flooding that most of you will probably have heard because it got a lot of press, the extremely heavy flooding in Dubai and Oman earlier this year, where we did a study. And how do we characterize an event is often really not straightforward. And in this case, so actually, you see here a timeline from the 5th of April until the 17th of April, just everyday rainfall over the area. And in this case, we have decided that, okay, it didn't rain much the first week. It started to rain on the 13th of April in Oman. And then on the 15th of April, there was really heavy rainfall, and that was when also most of the impacts occurred, and then it sort of petered out. And you could say, okay, for this, maybe what caused the impacts is really all the rainfall accumulated over these 3 days. But in this case, we choose to just focus on the 1-day precipitation. And this is partly because that was when it rained most, but it's also because the 1-day maximum rainfall in a year is something that a lot of climate scientists have looked at in a lot of papers. So if we use that definition, we can compare our results very easily with a lot of published literature. If we had chosen a different definition, then that would be our study, and the comparison would be much harder. And because it's a region where the climate models really had a very hard time to get the rainfall right, we choose to focus on this standard definition. But in many cases, you might argue it's actually, well, you're interested in the event that led to the impacts, and the impacts sort of were caused by this accumulated 3-day rainfall, so shouldn't you look at that? And there's not a right or wrong, but whatever you choose, it will determine the results, hopefully not qualitatively, so hopefully it will not be so different from that you will, with one definition, find there is a role of climate change, with the other you won't find it, although that can happen, and then that obviously also tells you something, that your results are maybe not as robust as you would like them. But the quantitative result is always extremely dependent on how you choose to characterize this event, and I think that's and because, especially in the media, people are always very excited about the number. You hear a lot about, okay, this is 30 times more likely. But actually, the number itself is really not that informative. It's really more the order of magnitude. And I think this is true for rainfall. Of course, you can do the same thing for drought. I don't want to go into details of that. There are lots of different ways of how you can define a drought. And if you just look at the lack of rainfall, you will find many fewer droughts that have a role of climate change. But if you're interested in agricultural drought, so the combination of rainfall and evapotranspiration, that's relevant for how much water is in the soil, how much water is there for agriculture, for plants, you will much more often find that climate change played a role, mainly because climate change affects temperature so much. So I don't want to go into detail, but this is also, it really matters how you ask the question. And that is, of course, is even more true for the more complex the event you look into. So temperature is pretty straightforward. Rainfall is usually also straightforward because you have one variable to look at and then just have to decide on a time frame and the spatial extent. But when you look at something like the massive fires last year in Canada, you have to look at temperature, but also humidity and wind speeds, and also at the sort of how dry was the soil and therefore the vegetation beforehand. And so you have a whole host of indices of fire weather to choose from. And so in this case, we choose the Canadian Fire Weather Index, which seems to make sense for studying Canadian fire, but we actually also have used the same one for Australia, and we have done a different study in Canada where we have used a different one because in a different part of Canada it corresponded less good with the burnt area, but this is how we choose this, and we've only focused on this area in Quebec, even though there were also fires in much more western part of Canada, but that has a very different kind of vegetation, so we would have to choose a very different way to characterize the event, which is why we only focused on this one. And in this one, we found that climate change about doubled the likelihood. And again, so this number is really just true for this specific way of looking at the event. But of course, the fact that climate change did make the conditions that were conducive to these fires much more likely is something that is relevant much more broader and holds more broader. And that really is the important part of every study. So this is what people usually talk about when they talk about my work. This is what where I put a lot of my career into developing the methodology. But actually, and that's particularly became more and more obvious, I think, in recent years when we had a bit more capacity to do the studies because we had a larger team and also more people in the Red Cross Climate Center working with us, that of course what turns a weather event into disaster has often very little to do with the hazard, with the weather event itself. It's totally driven by vulnerability and exposure. And so where we have developed most in terms of methodology, and where I think is often the main part of the story for an extreme weather event lies, is in the vulnerability and exposure. And so because of course the same weather event can have vastly different impacts depending on where it occurs. And so we looked at one extreme rainfall event last year, Storm Daniel, that hit the Mediterranean, Greece and Libya within a day. It was the same weather event. And in Greece, as you can see at the bottom, 17 people were killed and there were infrastructure damages. But in Libya, in the country that has been torn with war and conflict for decades, more than 4,000 people died of the same event because there was no early warning, so the institutional component, but also people lived, of course, in much more informal housing. There was no maintenance of the dams, and so the dams broke, and but because they were not maintained, people didn't know that they were likely to break, and had also no awareness that there is a danger. And all these factors play they are the central role to what turns a physical hazard into a disaster. And even if climate change plays a major role, like for example with heat waves, it's also it's always the vulnerability that determines how many people die, how many people are affected. And so we used to focus very much in our communication about this point here, this 5 times more likely. But I think actually that's probably the least important point of the studies that we're doing. But the other points that I've just highlighted here, that, well, this heat wave, for example, in West Asia, which also got a lot of press because it affected Palestine, and therefore people in refugee camps died, and they are of course extremely vulnerable to extreme heat because of the heat itself, but also because of the lack of availability of water and medication and so on. But no one needs to die from heat, in theory. There are relatively simple things that you can do, and they are sort of summed up here as the term heat action plan. But there's a lot you can do in the event of a heat wave if you can make public buildings that are cooled available for people, if people are aware of the dangers of heat wave, if there's water available publicly for people, but also, of course, longer term, there are more actions that need to be done. And I just realized today that Montreal is really not a city built for heat. There's hardly any shade, there's hardly any greenery, and everything is concrete and asphalt. So there's clearly also a long-term need to change things. But this is something where also, as I said, there are simple things that can at least get the death toll down dramatically, and there are good examples from India, for example. And then the last point, we always talked about climate change and then realized that in the media reporting, the reasons for climate change were never part of the story. And so we have now, in all our communication, in all our press briefings, the fossil fuels are now highlighted. So this is really some lessons learned in that we learned in how to talk about these extreme events that I think are almost as important as developing the methodologies to do the studies. And just very briefly, why does that matter apart from, well, we need to understand what climate change is, and it hopefully will help to also raise awareness of the dangers, but also, especially with the things like heat action plans and adaptation, just also show that there's a lot of agency locally for people to do something about it. But of course, there are other avenues where these studies go. And one of them that Damon has asked me to talk about, but is the courts. And I think I said at the beginning that we care about climate change because it affects people and because it affects the human rights of people and very basic human rights. And this is not just me saying that. This is actually part of the Paris Agreement. So this is here, the text you can see here is the preamble of the Paris Agreement, which talks about, well, we acknowledge that climate change is a common concern of humankind, and that there are particularly vulnerable groups, and that this is why we care about it. So at the preamble, in the framing of the Paris Agreement, justice is a big part. But actually in the way then the rest of the document, and also especially how it is addressed currently today in climate policy, which is mostly all about net zero and getting emissions down, which of course is important, but it also matters how you do it, and it matters what else you do. And so these attribution studies are used partly, at least slowly now, in courts to try to make this, to try and pressure policymakers, but also companies like the major fossil fuel companies to change their business model and to do more. And it's often done under the umbrella of human rights law. It's not always, but often. And just very briefly, so this was one milestone court case that happened a couple of years ago, where the Supreme Court of the Netherlands found that the Netherlands have not done enough and actually violated human rights because they have not done enough in terms of getting emissions down. And that was one of the very first really successful court cases where a state has been forced to make better climate policy. That was not about, this is just about the future, so this was not about current losses and damages. But of course, current losses and damages are also a big problem, and there are increasingly a number of court cases that try to get either compensation for current losses and damages that have incurred, or, and this is one that is also a really important case that was just last month. No, we already have June. Okay, 2 months ago, in front of the European Court of Human Rights, where a group of, they called themselves Klimasenioren, so a group of elderly Swiss women have sued the Swiss government, or they first have sued the Swiss government, and then the Swiss court system has said, okay, no, you have no case, this is not a problem. But then the European Court of Human Rights has said, no, this is a human rights violation. We have to rule this. And this is, I think, the ruling itself, it forces the Swiss government to do better climate policy. They have already said they will ignore that. So the ruling itself is not so important. But the fact that they said the Swiss government has violated the human rights of these people and their right to family, their right to a decent life is really a milestone, and that I think will probably help to get more cases like that, and then hopefully also better climate policies. And to just before I end, just two other cases that are important from a sort of extreme weather and loss and damage point of view. So one is one that didn't get much attention, but is the first successful case before the Klimasenioren that actually used attribution studies as part of the evidence in court. And this is the Bushfire Survivors for Climate Action against Environmental Protection Authority in Australia, where a group of an NGO founded after the bushfires in 2019-2020 sued the EPA for not protecting them from these extreme weather events that get worse with climate change, like the bushfires in 2020-2019, and that was the first case, the first successful case I'm aware of that used attribution science as explicitly as evidence to show your actions have caused these damages, and therefore you have to do better. And there has not been a case yet, a successful one, that actually afforded compensation to anyone who has suffered losses. But there is one that is currently ongoing in Germany, where a Peruvian farmer is suing RWE, which is the largest German fossil fuel company, for damages that occurred to him, flooding of the Lake Juarez because of extreme glacier melt that is caused by burning of fossil fuels. And this has been dismissed by the first court, but is now actually accepted at the higher court in Hamm, which is a city in Germany no one ever has heard of, but the court sits there. And this is insofar really important because it takes forever, but the judges have taken an enormous effort to go to Peru, to talk to lots and lots of climate scientists, to really educate themselves to understand what's happening, why it's happening. And of course, RWE is trying very hard to dismiss everything, but even if they will not grant this Luciano Luya the money that he asked for, it would be a milestone case because the court says this is clearly something that belongs to the courts. You have clearly done something wrong, RWE, by just continuing your business model with burning coal and not having any intention to stop it. So therefore, this is a really important case. And it might be that there will be some more of these. So this is not a panacea. It won't solve all the problems, but I think with some of these cases that have recently been successful, it could maybe really make a change. Yeah, I'll leave it at that.
Yes, Rebecca, would you like to ask a question?
We'll just get a microphone over to you.
Sorry, thank you so much. Hi, everyone. This always makes me feel like I should sing. I had a gazillion questions, but just based on the last part of your talk, I'm wondering about the way that you choose which, or your research group chooses which events to focus on has to do with mortality rates, some of which, yes?
Yes.
And people are more likely to die. It's more likely to be the vulnerable who die, those who do not have power and money to litigate. I'm just wondering whether it's occurred to anybody to focus on, Damon can tell you all about who's emitting the most, and to make some political decisions a little bit about where the focus is. Maybe not only on the places where the most people have died, but on the places where the most emitters are. And so, maybe people aren't dying, but maybe we're really mad that it was very smoky here last summer. And if we had evidence that that was, due to climate change, maybe we would get more action in the places where action is needed the most. I know you're a scientist, and so I guess I'm asking about, where you draw the line in terms of your research about where to focus and why.
I mean, it was a very political decision to focus on humanitarian impacts because The first, and we started to do that and develop the methodology to do that in a sort of in a more transparent and systematic way 3 years ago. Before that, we did studies on, well, whatever events we felt where there were lots of questions and we had to do it. And of course, well, my team with World Weather Attribution, we are doing this very publicly and quickly, so you often hear from us. But there are other people who do this on a sort of science timescale. So there are other groups who do attribution on a climate science timescale, and a lot of them are actually based in the US. So there are lots and lots of attribution studies for events in the US. There are lots of attribution studies for events in Europe, but where there were basically, up until 3 years ago, there were 2 for the whole African continent. And that is why we have decided we start to focus on the humanitarian impacts and bring science into the parts where there isn't much. But that doesn't, of course, that doesn't mean that you shouldn't do attribution studies where the emitters sit. I think I personally don't do the US because there are lots of scientists in the US who can do US events, but that's, yeah, and I mean, we also, with my team or with other people, I would also do a study if it feels this would be important or could be important in the context of a court case.
Okay, thank you. I in no way meant to say that it's not important to do it in places where people are more vulnerable, but just maybe it's also important to do it where people aren't dying but are emitting a lot. Thanks so much.
Yeah. Thank you very much for your talk. It's really a great pleasure to have you here at Concordia, so welcome. So I am an adaptation researcher, and I do a lot of work on adaptation assessment. So that includes kind of formal monitoring and evaluation, as well as more kind of scientific, systematic peer, like literature reviews, that sort of thing. And this is a topic that's becoming a lot more sort of in demand. There's a lot of interest growing around it now. How do we assess essentially whether or not we're effectively reducing, risks in the present term and vulnerability long term? And that presents a lot of, conceptual and methodological challenges. But in some sense, we also use the word attribution. How do we attribute changes in outcomes we're interested in to a particular set or individual adaptation response? So I'm just curious if you have any thoughts or kind of recommendations for this kind of subfield within adaptation governance, which is now starting to grow pretty rapidly, what we can learn from your experience with weather attribution science, and how to kind of approach that, both knowing kind of political and institutional contexts in which that information is going to be received, as well as, I don't know, just any advice, I guess, you have for a field I think that's going to start growing pretty quickly in the next few years.
I mean, that's a big question.
Sorry.
And it's a field where there's clearly huge need for more systematic assessment of what actually works, how can we monitor what works and what doesn't. And so I think there are some countries where we find that it's much easier to find out what's actually happening, who has the data, who has the knowledge, and I think one of the first hurdles would be to identify who should actually monitor this and how can we monitor this. And I think there is, so again, India is a relatively good example where they have a very close collaboration between the Met agencies and agencies that develop heat action plans. So you have information there, at least in some cities, and that of course means that you can benchmark, okay, this city has a heat action plan, this city doesn't, but is otherwise relatively similar. And I think that kind of information is, I only know that exists in India. I don't know any other country where we actually have these comparisons and can see which of these simple things does work and what doesn't. So I think for me, that seems the most obvious gap. But yeah, I mean, it's a huge field, and I'm not a social scientist, so I think the conceptual way to think about it is also something that that to me feels still a bit missing, or at least missing in terms of communication outside of this quite small social science field that is looking at stuff like climate resilient development is sort of a buzzword, and there are global picture ideas, but how you actually implement that on a country level, on a state level, is something that I would love to know.
So I'll ask a question. I'll pass it to you in a sec, Jochen. So one thing I've noticed in the last 10 years, and you kind of alluded to this as well, that I mean, it used to be the case that the standard scientific answer to was this event X caused by climate was, oh, we can't like attribute any particular event to global warming, and so kind of dodging the question, not being particularly straightforward. But I do think that has shifted, and more and more people are saying things like, climate change is contributing to all of the weather events that we see, or like climate is like a fun, yes, and here's why or something. But so I'm wondering what is that the right answer to this question, or would you give a different answer?
Well, I would say that the answer, climate change affecting all these events, I mean, it's trivially true. Obviously, climate change, all events that are happening today are now happening in a changed climate. But climate change actually affects them very differently, depending on the type of event and also depending on the region. And I think we have actually gone a bit, I feel, publicly from when we talked about, oh, we don't really know, to, oh yeah, this is all climate change, which I think is as unhelpful, because it then makes climate change as God, and it was all an act of God, and there's nothing we could locally have done or we could locally do to make things better. And I think that is quite dangerous. And also, it's wrong in that way that there are events that are not massively affected by climate change. I mean, some of them have a very small climate change signal, and some of them, of course, are actually less bad, like cold waves, because of climate change. And so I think it doesn't help to give this blanket statement, but I think it's not so problematic that it's scientifically not quite accurate, but I think that it takes agency away from adapting, from reducing vulnerability, from doing stuff, is why it's dangerous, I think.
Would you like to ask your question, Jochen?
Thank you. So our department started a climate emergency committee 5 years ago, and we were wondering what can we do. So I could mention a few things that we have done. So we sent letters to the various universities and schools and CJEPs to include climate change in the curriculum, which is not the case. Now the Quebec government is talking about doing this in 5 years. So why don't they not do that tomorrow? Why do they wait another 5 years? Those are all the questions. But I'm curious, do you have suggestions, ideas? Like if you think about students who are 20 years old, what can they do? Where do you see they can make a difference?
So I think for me, the most important thing is how we talk about climate change, because a lot of, especially young people, are aware that climate change is a thing. But I think especially the generation that's probably not now in their early 20s have this idea that when we reach 1.5 degrees, there's this asteroid falling on our head, there is this cliff we fall under, and then the world will be uninhabitable. And that's not what how climate change feels like. It doesn't feel like this today. It won't feel like this when we reach 1.5 degrees. It even won't feel like this when we reach 2 degrees for everyone. It has felt like this for some people when we had 0.8 degrees, and it obviously will feel like this for more people when we have 1.4 degrees. But it's not something. It's something that manifests very differently for different people depending on vulnerability. So I think talking about climate change more in the context of human rights, and that it destroys livelihoods or increases food prices, which of course is a much bigger problem for someone who has a much larger proportion of their income they spend on food. I think that's what's really missing in the understanding of the vast majority of people what climate change is. We've always talked about it as a physical thing that has a technological fix. And that I think is partly why, so the UK government, they had by far the largest proportion of the funding they put for climate policy, they put into research for carbon capture and storage, which is ridiculous because there are so many simple and straightforward things that we have known for decades we need to do that need to be done, that would also, of course, like having better housing laws that you can't build houses that are not insulated anymore would be something that would be necessary, not only help with climate change, but also help with the cost of living crisis and so on. But because I think the vast majority of people doesn't really know that everything hangs together, that climate change is not an extra problem that affects polar bears and we can deal with in our spare time. I think that is the biggest issue, and education on that, for me, seems the most important thing that people now can do.
There's a hand in the back. Corey, yes.
Hello. Two questions. First question is about quantitative impacts attribution. So you had good motivation at the beginning of your talk talk a lot about 2 meter air temperature, but ultimately we care about it because it causes impacts. And there's been a big increase in the sophistication of attributing the surface variables of climate. There's some quantitative stuff about attributing impacts, but it seems like there's a lot more that's quantitative. So I just wanted to ask you where we're at on quantitative, probabilistic impacts attributions, particularly from organized systematic efforts. There are a few papers around, I know, or a lot of papers actually. Second question is about how the courts see climate science as evidence. I've been kind of surprised the last few years that courts seem to just take climate model evidence as completely admissible evidence. They're very supportive of it, enthusiastic about it. But they're both kind of operating with some principles in common, some principles quite different, evidentiary standards and burdens of responsibility. So I just wanted to ask you about where you see those two kind of modes of reasoning fitting together.
So I think the first question on impact attribution, as you said, there are quite a few papers around that do that. There are also a lot of them use slightly different approach. Don't look at individual impacts or individual events and see what the role of climate change is, but look more at crop yields across a continent or crop yields across the world. How have they changed, or how are they likely to change? So that's I would say the standard method of impact attribution. So which is of course, you can't just marry that with a study like ours where we look at individual events. But there are also a few where you go down from the meteorology to then also employ hydrological models and see, how much of the actual flooding has, and not just rainfall, is attributable. I think the reason that it's not sort of part of our I wouldn't say it's systematic, but it's more rapid or more responsive is just because it's, climate models are readily available. You can just use them and they all do more or less the same thing because they have the same physics, whereas impact models are usually not built on physics, but are just empirical models. And so you need to have much more knowledge, much more understanding to have different impact models and to actually be able to interpret their results. And we don't have that in our team. and we can't, I mean, we are trying to do these studies within a week or two after the event so that when the media is reporting on the events, they have some scientific evidence. And that's, for us, it's just not something we are able to do that quickly. And although, of course, there are other people doing attribution studies, it's still a very small field. That's, I think, just why it seems really slow in having more impact attribution studies. But for example, the Klimasenioren case, that used a study that did actually attribute mortality in Switzerland so these studies do exist. And I guess that's the second question. Yeah, I mean, judges are ultimately the same as the general public. So there are some that are really well educated and take meaningful look at the evidence in a meaningful way. There are some that have no idea what they are actually looking at, and so they either say. So we have a PhD student of mine has done a study looking at 80 different cases on loss claims in front of the courts, and looked at the climate science evidence and found that most of it used sort of evidence that was 10 years out of date, and also a lot of them just presumed attribution. So a bit like, oh, well, it has happened today, so it must be climate change, so that part is fine. But of course, those were all cases that haven't actually gone very far, but have been dismissed on judicial grounds earlier. So it's really hard to actually know. And I think the one thing that we do know is if it's in the IPCC, then it's fine. But of course, the IPCC is not very localized, and so for all the loss claims, it will be difficult. And I think there is some work to do with the law community and the science community to come together. And I think, well, that's also some part of the work that you are involved in, right?
Yeah, I mean, a little bit. I was involved in one law case that did make it to court and was ultimately not successful, but actually made it quite far in Canada. I mean, yeah, it's a really interesting experience working with the lawyers and observing the types of things they wanted to know. And I mean, in this case, it was a question of how do you scientifically define responsibility and emission shares for a province of Canada. So, for me, that's a very subjective exercise and very difficult to answer from a purely scientific point of view. I mean, I was wondering, so one thing you talked about is the distinction between the physical risk and the human dimension of response. I mean, listening to that, I was wondering how that might play out in a legal argument as well, if the physical risk is actually not the primary driver of mortality. How important does that become as a piece of legal evidence when you're trying to attribute liability for a particular event?
I mean, that's a really good question. And I've just been last week at a conference in Copenhagen with lawyers where we tried to sort of come together in that. I think there is no, there is one standard legal way to go about it, which is called the thin skull rule, which basically means that you have to take your victim or the person who has suffered the harm as it is. So if the person is very vulnerable because of where they live or because of some physical conditions, then or maybe even because of stupid decisions they made early in their life themselves, you still have to take them as they are and then see, okay, what was the role of the hazard? So that's one approach, and that's, for example, what the judges are, well, it's not final yet, but have so far been saying for the case with Luya against RWE, where RWE has said, oh, but the Spaniards have actually built this city at a very stupid place. So it's nothing to do with us. It's all the vulnerability. And there the judges have said, no, this is clearly not the question here. It is what additional risk has come from climate change. So that's, in my view, is probably the most sensible way to do with it in this kind of loss claims. But of course, if it's what governments need, claims where it's about what governments need to do, or differential responsibility. So assume, I don't think there is one, but if we had a case that is brought, that Pakistan brings, say, against the US for the floods in Pakistan that happened in 2020, where there's clearly a role of climate change in that, but there's also clearly a role of just the colonial past. So a lot of the water infrastructure in Pakistan has been built by the British colonialists. They were mainly built to look good, so but not actually to serve very well, especially people in the villages. So there's a clear role of that. And then, of course, Pakistan also had, in 2010, very heavy flooding. They had a very thorough assessment of everything they need to change in Pakistan to save people, and they have done nothing of all these things. So there are clearly at least three sort of major causes. One is climate change, so burning of fossil fuels, mainly the global north, but then also colonialism, and then also locally. So I think in these cases, it will be much, much harder to answer that question of how do you deal with these other drivers of vulnerability and exposure. And I don't have an answer, and I don't think the legal community has an answer yet, but this is something that really needs to be addressed urgently.
Damon, I'll just jump in and mention we do have a question on Zoom, and we welcome anyone else joining us on Zoom to just add another question in the chat. This one's from James Grant, and Jim, if you want to turn on your microphone and reframe, you can, but I'm going to read it. How do those being sued attack the science of attribution, and have these attacks affected the way that you do science?
So I think how is the science attacked is, again, I know it from the RWE case, where then a bunch of scientists paid for by RWE published a paper I mean, you can publish anything in a scientific journal. If you just find some random journal, they will publish anything. So they have published a study that says, oh, climate change has nothing to do with this. And you could assume, okay, then you have the battle of the experts. So we have one study that shows, oh, this glacier would never have melted if it wasn't for climate change. And then you have this other study, and that's all you have. But of course, that's not all you have, because it's relatively, when you read that paper that the RWE paid scientists published, they choose a very random time scale in which they looked at, they made lots and lots of very obvious mistakes. But even if they hadn't done that, the paper that shows that this glacier is only melting because of climate change is one part of a large, I would call it causal field. There are lots of papers on not exactly the same glacier, but similar glaciers across the world that all show the same thing. And they all have developed the methodology, and you can see that, I mean, this one paper uses the standard methodology that has also been used in IPCC reports and so on. Whereas this other does something very random. And so so this is, I think, how it affects science is just that you show, I think how it affects science, for me at least, is you show much more, you're much more thorough in your papers to say why you've used it and who else has used these methods and how your science fits into the bigger picture. I think that I would say has been quite a positive influence from these court cases, that if you write a paper, you don't just write a paper, but you try and situate it much more in the broader science. But of course, that's also where it's important that judges have at least some understanding of the science, so that they are able to make, or at least that they are able to identify which scientists would be good as reviewers and advise them, and which scientists are just random people paid by RWE. So I think that level of education is necessary.
Sorry, I just noticed, Alex, you put your hand up earlier. Did you want to respond to the previous discussion, or? Okay, let's do that, then we'll move to Emma, maybe next.
Well, I did have a question that was kind of... Go ahead. Yeah, I did have a question that was kind of...
You have to pass the microphone back.
So it was a question kind of following up on yours, but looking at who you would attribute the damage to. Is it states or corporations? And so, for example, why RWE and not any other greenhouse gas emitter? And
So that's easy, because in German law, you are responsible for damages that you as a company cause, no matter where these damages happen. Whereas for US law, you are not. You're only responsible for the damages that occur in US territory. So that's why RWE and not Exxon.
right.
So that's purely legal, strategic point.
Okay. Right, and so then if you were after Exxon, you'd have to go after the United States for not having good laws. Because Exxon
Or
are operating
if you
within
want
the
to
law.
go, there are actually ongoing cases right now. So there's one where Oregon County is suing Exxon and 10 other
Bunch of different companies, yeah.
10 other different companies for the damages that their business model have caused Oregon, particularly the heat wave in 2021. So but you have to find the damage. If you want to use US law or you want to sue a US company, you have to find the damage within US territory. Yeah, seems crazy, but that's, I mean, that's the hardest. It's also, I mean, one of the hardest parts of these law cases is, of course, it's not illegal to burn fossil fuels. So you have to find other laws and legal avenues to still show that, well, but you know that your business model is killing people, and therefore, even if it's not illegal, you should have not done it. So these things are really very much depending on what laws are in what states and who can use them.
So this is maybe not a fair question, but do you think in the context of the Canadian wildfires, there'd be a case against the Canadian government?
I mean, I don't think Canada is that great in reducing emissions.
No.
So I think I could see how that could be a case, yeah.
I mean, there is an interesting question, I think, about like who is responsible, and it sounds like your answer is partly just if there's a legal opportunity, you go for it.
I mean, I think it's both. It's the states for not making the laws, but I think it's also the companies for, lobbying the states to not making the laws on a massive, massive scale, and also having a business model that actively kills people. I think both are, in my view, fairly valid avenues to go.
Thank you.
Alex, do you want to circle back to, okay.
Yes, so one question that's come up more recently in Canada is whether municipalities should be held liable for, for example, continuing to allow new housing development in areas that we know are already at flood risk and will become even more at risk, most likely under a changing climate. Are you aware of any cases that have been filed at that more local level, municipal level, regional level, that uses attribution science or any of these other kind of scientific sources of information? A lot of what we talk about are big blockbuster cases, Supreme Court cases, or big national companies. But curious about the more local.
I'm not aware of any, but that doesn't mean they don't exist. I mean, I'm not a lawyer. I work a lot with legal scholar, but mainly international legal scholars. So which is why the big picture question. But I mean, there are thousands of cases in the U.S. alone So I would assume there are, because it's an obvious thing, I would assume they are, but I just don't know. Sorry.
Just curious, thank you.
I think other Alex had a question, yeah.
I was just wondering what the change in the past decade or so in that we see a lot more attribution, weather attribution related to climate change. Is it from changes in computing power and models, or is it really just like an institutional, like there's more research behind it? Like why are we seeing a lot more of it recently than we did in the past?
So I think it's a mixture. It's a mixture of, first of all, I mean, the first attribution study was published exactly 20 years ago, so in 2004. I think, so one, and then there were, in that sort of between 2004 and 2014, there was maybe globally a handful or 10 studies. And then there were a few, mainly around the Russian heat wave in 2010, there were a few studies that were quite prominent. So, and I think one reason why it sped up then is that just scientists got the idea that, okay, this is actually something that you can do. So that I think, and before it wasn't really, and it's also it was also in the IPCC report in AR5, so that was published in 2013. It was first that you can do event attribution was first mentioned there. So I think that played a big role, that scientists just thought, okay, this is safe now. I can do it. I won't be accused of being crazy. And then I think one other big thing is computing power, and particularly democratizing of models, because up until, well, I'm not quite sure exactly what year, the climate center, the modeling centers that would run the models were the only ones who sort of were allowed to use the data and to use the models. And that has changed over the last decade, that now almost all the modeling centers put the data on publicly available servers. So all the climate scientists can do these kind of science now. So that I think is the other big thing. And of course, I think the last thing is just climate change, because especially in the last, I mean, it feels like the last 3 years have just been absolutely crazy in terms of extreme events. But of course, also the emissions have gone up so much in the last 10 years that you now see the climate change signal in events where you didn't, or where you at least would have had to work much harder to see it just 10 years ago.
Jochen, you had another question? You have to get the mic.
I love your book, and it's one of the few books that is hopeful about this topic. So my question is, will there be a second edition anytime soon where you can elaborate a bit more, as you did in your talk, about those court cases and where attribution science has been used, and make the book even more hopeful?
I'm not sure if the latter, but I actually have written a second book that will be published in either later this year or early next year in English. That's very much more on the climate justice. It's called Climate Injustice, and it's very much more on the, I say, big picture question rather than the science itself. So you can pester the publisher to make it a bit faster. I don't know. It's done. It's written. The translation is done. I don't know why it takes so long.
Is it available in German?
Yes.
Oh, it's already. I didn't see that. Okay.
Yeah, it's available in German, but I mean, I have a translation. I can give you a PDF if you like.
Well, we had a discussion in our Climate Emergency Committee that there's so much bad news that we should try to find some good examples, and rather than being all discouraged and despair about the situation, find good examples. Like, if you want to add to that.
Yeah, something we've been focusing on with the Climate Emergency Committee, and I've seen it in general in a lot of climate activism now, is there's a lot more focus on the progress and developing hope so that people don't get the doomerism mindset, and especially so that younger generations have a future to imagine. And yeah, I mean, that's been part of what we've been focusing on lately. And yeah, I'm curious, in your new book, do you have that sort of viewpoint that you're trying to push forward?
I mean, I definitely don't have the doomerism point. I think a lot of it is about, these are things that go wrong, but they are actually things that go wrong that you have quite a lot of agency to change them on a sort of local scale. But I think the future to imagine, I think that's the most important point that I feel that we as we are all sort of loosely part of the climate movement in different roles, are missing. That all our stories, all our narratives are still very much based on this fossil fuel world. So freedom is driving in a convertible across Route 66 or something. So every time I go to the cinema, I get car advert after car advert after car advert, and then all these free and hopeful people. And when people ask me, okay, what would the future look like? You can, of course, explain it and I always explain it in what feels very sterile terms. So we would have greener cities, and we would have the city centers would be much more alive, which for me feels great, but we don't have the images, we don't have the stories, we don't have the big blockbuster movies that sort of live in this different world. And I think that's something where we are really struggling, where it's all very sensible, but it's not cool, it's not fun, I found in the meantime, after I published that book, I said I don't know any good books, and then lots of people have written to me and said, oh, but there are good books that do this. And so I found a few now where there are actually some of these stories where I feel, yeah, this is getting there, but they are at the moment, I think, very niche and I think that's something that we should try to have much more. And of course, it's not necessarily something that a scientist is very good at, but there are lots of other people out there who are good at that. So that, for me, is what's really missing and what we need much more for this hopeful message. Because I totally think we should be hopeful, and we have to be hopeful. We just can't afford to not be.
So we've talked a lot about the legal applications of attribution science. I mean, there must also be interest from insurance industry and banks and that side of thing. Have you had any experience with that sector?
Yes. So the insurance industry is they are really good at running their own models, and they usually, the insurance policies are sort of annual. So you need to get the now right, which is not so hard if you don't care so much about the future, and especially insurance industry doesn't care about heat waves, because that's not something you insure. They care about hurricanes particularly, and they care about rainfall and that, and so they do use the data that we use, but they don't necessarily need to work with us because they have their in-house expertise. I think banks should pay much more attention, and I know that the European Central Bank and the Bank of England, they have tried now to actually include climate change in their stress testing, but I think that's something where, if scientists who like this kind of world. I personally, I love working with lawyers, but I don't love particularly working with bankers. I just find it very difficult to find a language to speak, the same language to speak. But there is actually huge interest with a lot of banks to how can they incorporate that better, and how can they do stress testing that actually works, because a lot of that sector thinks that, oh, but if you can't give me one exact number, then I can't use your information, which of course is, I mean, that's not how science works. You will never get one exact number, but that's been, I think, a big hurdle where there has been some understanding that that might not be the right way to do it. But what is the right way to do it, I think, is still a relatively open question. But at least in Europe, there's quite a lot of interest from banks. And
do you think that like science is changing people's minds on this score, like or attribution science in particular? Like, do you think, and like, what else do you think we need to change people's minds about how serious this issue is?
I mean, part of what else is what I just said about the changing the narratives, and actually showing that it's not about taking something away from people and saving polar bears, but that it's much more about making your own life better. I think that story hasn't been told very well yet, or at least not understood. I think attribution science has helped to make climate change much more real, to at least the science community, within the science community and beyond, to actually show where climate change, like with heat wave, it's an absolute game changer, but also that it sometimes is a relatively small change, but that's actually very, very crucial, because it's pushing thresholds from crops or so on over the edge. And I think that their attribution science really, really has helped. Yeah, I mean, what do we need to make change more quickly is I think in some countries more attribution science, but I think in a few countries, like a lot of Europe, actually the US, I think most people do know, but don't want to know. But there are other countries where I think attribution science can still push the understanding, and where it's still much more necessary. I think here I think attribution science is helpful because it gives the evidence, and it also shows sort of the different scales of climate change, but it's not very necessary or helpful anymore to show that climate change is real and that it's here. I think there it's really much different questions, political questions of how to change things.
Where do you think we're headed? I mean, we've seen 1.3 degrees already. 1.5 is, probably less than 10 years away. What do you think is going to happen after that?
That's a mean question.
So, okay, let me preface it then. Like, there have been a few different surveys of climate science that have been in the media recently, and by and large, it seems like the science community thinks we're going to end up at around 3 degrees, which is kind of the scenario, the current business as usual. It kind of implies that we're not going to manage to do any better than we're doing right now.
I think we can do better, and I think it really, really depends on, so we have seen, it really depends on, I mean, this is a big election year, and it really depends on what in some of these elections will happen, I think, of how much closer we are to 3 degrees than to 1.5 degrees. And we have seen, for example, in Brazil, 4 years of Bolsonaro really have made huge damage in terms of the protection of the Amazon rainforest, dismantling a lot of institutions. And so now Lula is really trying hard to get that back. And I mean, we just have the election results for Mexico, which seem quite hopeful. In Poland, we had a super right-wing government for years. That has changed back now. So I think things can change quite quickly. And it, of course, how close we are to 3 degrees or 1.5 degrees crucially depends on who is leading the big emitting countries. And I mean, I don't want to make predictions on how that's going to end, but I think that is, I don't think at all that it's clear that we end up with 3 degrees.
Either or. Whoever was closest to the microphone. Let's go with Emma first.
Emma.
I don't know. This is maybe a very big question, but it's about attribution science, not only for climate. I mean, arguably climate is the most important question, but the issue with tobacco and cigarettes was kind of a similar question of how do you prove not only a general principle, but specific cases, and in the face of a very strong lobby trying to get out of it. Questions with junk food and ultra-processed foods, it's the same thing. I've been involved with a similar question on a very, very small scale of how do we prove that specific policies relative to people and dogs are causing conservation problems in one specific small protected area. And in that case, obviously we can't. We don't have a study for this one space, but I like the idea you had mentioned about the glaciers. Can't remember the language you used, that we might not have a study for this glacier, but we know for other glaciers. So I'm wondering if you could speak a bit more about, I guess, attribution science and how it works, and when do we feel that we need to prove that this particular case is due to this mechanism? When can we say, well, look, we know this mechanism works universally, it's going to work here too?
I mean, a causal field is the term
yeah.
that I used. And I think it is really actually important that we as a scientific community talk much more about this, because this is, I think people really don't know how science works. People think, oh, there is a genius and has an idea and writes a paper and there's your explanation for X. But that it is actually trying to do the same thing over and over again, or slightly different things with slightly different methods, and then you have this big field that answers the same question or is a very similar question in slightly different circumstances, and that is sort of the background of, and therefore then one study suddenly is really a proof, whereas if you don't have this field, then of course one study is one study and nothing more. So I think that is something that all of us, and also journalists really writing about science, I think would need to talk about much more, because it's so crucial. And actually, we got the idea to do attribution for weather from the tobacco litigation cases, where you had, okay, you can't prove that this cancer is only due to the cigarettes you smoked, but you can prove that it has increased the likelihood so much more. And yeah, I mean, it's the methods, how exactly you do it, of course, will be, and actually for climate, for weather events, it's quite easy, because you have all these climate models that are based on physical laws, so they are all, you can all use them together and therefore have a lot of data, whereas for a lot of things, you might only have, you don't have a model that's based on physical law, like you might only have a model that's empirical, so it's harder to do it. But I think as long as you have a physical or biological or strong scientific mechanism, that I think is the most important thing, which is also why I would say we don't need heat wave attribution studies anymore. We know what's going on, we have the physics, we have the models, we have the causal field. I mean, and if it's 30 times more likely or 100 times more likely, it really doesn't change anything. Whereas for droughts, for example, we still do need the individual studies, and lots of them, because we don't have the same physical reasoning, we don't have the same quality of data, and we also have a much smaller and much more regional differences. And so, yeah, I think you can't say globally, this is what you need to do to create a causal field, because for some things, it's much easier than for other things. But I think it would be really helpful to think more in this with this concept in mind when writing studies and also when talking about them.
So maybe on a related issue, in law, there's this idea of burden of proof, right? That if you've been accused of a crime, you don't have to prove that you're innocent, they have to prove you're guilty. So if there's a strong causal field, could we then flip it and say, no, we don't have to prove that this heat wave was due to climate change. You have to prove that your emissions are not causing heat waves.
Yes, I think
It seems logical.
yes, and I know that some lawyers are thinking about that. How can we because a lot of the arguments that the fossil fuel companies and also countries have, so the Netherlands in that case that I brought with Urgenda, the Netherlands have said, but we are only responsible for 0.5% of emissions. How could that be a problem? And there the courts have said, no, that is a problem, which is why this is a landmark case. But you could also say, well, if you're a small fossil fuel company, it will be hard to prove that you've statistically increased the likelihood of this particular heat wave. But of course, that doesn't mean that they have not caused that particular heat wave. So that would be a prime case where you say you have to change the burden of proof. Yeah, I mean, I'm not a lawyer. I don't know where you can do that and how easy that is. I don't think it's easy at all, but lawyers are thinking along these lines.
Yeah, because it often does become this kind of game of, well, prove it, and if you can't prove it, I'm not going to believe it. And yeah.
So we've kept Freddie here for quite a long time. Maybe one last question from Jochen, and then we'll close. And
I have a very quick question. You said it takes about a week or two. How fast do you think can it get? And my second question is, does AI play a role, or will AI have a role here, or is that not the case?
So I think a week is probably, at least the way how we do it, as fast as it gets. It's not, I mean, the computing, if the server works, which is not always a given, but that I think is a problem that can be resolved. That is really quick. That is a couple of hours, really, or even less. But what takes time for us is to figure out what has actually happened, which is sometimes it's relatively straightforward, but not always. So where did it rain? Was the rain that fell in the area that flooded actually the only cause, or was it that the whole season was completely soggy? So these kind of questions, getting access to observational data, that takes time. And then interpreting the results also takes time. And that's why I think we can't get faster. But I think you could, if you would do that in a different way, say you would run it as a meteorological service for a country. So the German Met Service has been talking for 5 years that they want to do their own attribution. They still haven't done it yet because they're still figuring out how to do it. But you could say, okay, in Germany, we have standardized heat wave definitions that we can just use them. We don't need to think about it. We can just crunch the numbers. We are not interested in the vulnerability and exposure. So I think that would be something. I would find that really helpful if Met Services would do that, because for your Met Services know much better than I do for their own country, what are the relevant variables, what are the relevant regions. We always have to talk to the people in the country and figure all these things out. So this would be something that would be really prime for a national service to do. So far, so the Australian service has this system implemented, but they don't make it public. You have to ask them why. The German Met Service is still, they have also the system implemented, but not quite the people yet. So the British Met Service occasionally do their own attribution studies, but they also don't have a team who does it routinely, so that's why it then also takes forever. But it's something that I think you could do, at least for things like heat waves and heavy rainfall and and maybe maybe even windstorms, although there you usually don't find a signal, but it's still something that you could routinely do, I think.
We need to start including it in weather forecasts as well then. So thank you, Dr. Otto, for being with us today. Thank you everyone for coming. Thank you also to the people on Zoom who joined. So we do have some coffee and snacks. We have this space until 5:30. If anyone would like to stick around and ask more informal questions, please do. And otherwise, let's bring this event to a close, and thank you again for coming.
Yes, thank you again, everyone, for coming in. Dr. Otto, Dr. Matthews. Thanks for coming to ForSpace and activating this conversation. Everyone online, those of you here in the space, thanks for all of your questions, engagement. We're going to be closing up the Zoom and the live stream now, but a reminder that the conversation remains available on our YouTube channel. Please revisit, reshare. And that's all I have to say.